I'm back to show you how to do some of these calculations. I just didn't want to make you sick by repositioning the camera and everything, so I thought it was better this way. So we're down here at the bottom, and we need to convert the internal diameter of the syringe to inches. So we have 3.00 centimeters. You may have a different value, so you will follow this same procedure. You just might not have the exact same answer as I do. So I want you to show your calculations on a separate sheet of paper. So grab a separate sheet of paper and write data on it, and you will staple this to the back of your lab. So for data number 1, I have 3.00 centimeters. And I'm going to do a conversion using my bridge notation, or Okay, so I know that 2.54 centimeters is 1 inch. So when I divide 3 by 2.54, I get 1.18 inches. Now, 3 significant digits for all of these. But for the next part, so that's my internal diameter in inches. For the next part though, I want to know the radius. Remember, the radius is half of the diameter. So for the next part, we're going to say radius equals 1.18 inches divided by 2. Now be careful here. This is a rule that I actually had to look up for significant digits to make sure I got it right. I'm going to write this as 0.59 inches. Yes, I went down to 2 significant digits because I cannot have more precision in my answer here than I measured originally. I only measured to the hundredths, so I can only have an answer to the hundredths. So I have gone down to 2 significant digits for that reason, because I cannot have a more precise answer here than I originally measured, because if I were going to just physically measure this, this is what I would have measured. So that's the radius of the syringe. Now for 2, I have to find the cross-sectional area of the syringe, and that is step 3 here. It says determine the cross-sectional area of the syringe in square inches, and the formula is A equals pi r squared. So A equals pi r squared. I'm going to say A equals pi times 0.59 inches squared. I'm leaving it as pi because when I do this on my calculator, I'm going to use the pi key. Okay? So I'm going to go ahead and put that into my calculator. I'm going to say 0.59 squared equals times pi. And I get a value of 1.0935, But I can only have 2 significant digits, so that's 1.1 inches squared. And that's the value I write in my data table. So I'll go ahead. Now you, like I said, yours may be different. I'm going to write my 1.18 inches, my 0.59 inches, and my 1.1 inches squared. You may have different answers, but that's okay as long as you're following the steps that I'm doing here. For 3, so I'm over here on my data table, and I'm going to write 3 to go with this right here. So, and I'm actually going to write 3C to show my work, because 3C is the average volume. So to find the average, I add the 2 numbers together and divide by 2. So I have 46.5 milliliters plus 40.5 milliliters divided by 2, because that's what I have here. Your numbers may be different. That's okay. Just follow the procedure. So add your numbers together, divide by 2. When I do that, I'd get 43.5 milliliters. Again, keeping my significant digits. Okay, 3 for these, 3 here. For D, this is 1 over the average volume. So I'm going to take 1 and divide that by 43.5 milliliters. And when I do that, I get this number. Okay, I need 3 significant digits, so it's 0.230 milliliters to the -1. Because this milliliters is on the bottom, I'm going to write it this way. Okay, to the -1 power. So that's how I get C and D. I'll do this one more time with my answer to 4 for the 500 milliliter. And then I'm going to ask you to do this for the rest of your answers, because I actually have to collect more data so I can do the graph with you. And I want to do it while my barometric pressure is still the same. I do not want that barometric pressure to change, or it could alter my graph. So for 4C, again, I'm going to average these two numbers. So I have 41.0 milliliters plus 34.0 milliliters. Add those together, divide by 2. When I do that, I get 37.5 milliliters. For D, it's 1 over 37.5 milliliters. And so my answer is 0.0267 milliliters to the -1. So that's how you do that calculation. Now, I went on weather.gov and I got my barometric pressure. I was going to try to see if I could bring that up, but I don't think I can for you guys. When I got my barometric pressure from weather.gov, and you can get this from any weather site, my value was 29.86 inches of mercury. But I want it in PSI. So on the very front page of this lab, they show you how to do that conversion. So I'm just going to do what they are showing here. So they told me that 29.92 inches of mercury is equal to 1 atmosphere. And 1 atmosphere is 14.7 psi. So when I multiply across the top, divide that by what's on the bottom, I get 14.7 psi. Notice basically atmospheric pressure, because these two numbers are not that different, okay? That's why I basically get 1 atmosphere, or average atmospheric pressure here. So I'm going to put that value here, 14.7. I'm also going to go back and put my average volume here of 43.5 milliliters and 0.230 milliliters to the -1. 37.5 milliliters, 267 milliliters to the -1. I think I left off a 0 here. I better double check. 1 divided by 43.5. Yep, I did. So be careful of things like that. Just transferring the wrong number. It happens to the best of us. So go back and double check your numbers. If they don't make sense, fix them. Okay, so you continue doing that. I want to see all of your calculations here, and I will have another video probably before next week in case some of you just want to get these calculations done. I'll have it within the next couple of days on how to do the calculations for this data table down here, but I'm not going to do it tonight. I've got to get my girls to bed. So have a good night or a good day or whatever time of day it is. And I'll be back with some more calculations for you.